In this video, we're going to discuss the relationships between trig functions between the angles of theta and pi minus theta, theta and 2 pi minus theta, and theta and pi plus theta. So let's talk about the relationship between trig functions when the angles we're comparing are theta and pi minus theta. To help you visualize this, remember pi is equal to 180 degrees. So if I have an angle theta in the first quadrant, then the angle pi minus theta will be in the second quadrant. So using this as a guide, let's imagine that we were talking about the sine of theta and the sine of pi minus theta. Well, the sine of theta would be equal to the length of this vertical line right here, and the sine of pi minus theta would be equal to the length of this vertical line right here. They're both positive. So in other words, the sine of theta equals the sine of pi minus theta. And it's true regardless of what quadrant theta is in. Well, now let's look at cosine. Well, the cosine of an angle is the x-coordinate. So the cosine of theta would be equal to this terminal arm, and it would be positive because that x-coordinate's positive. Now this terminal arm, the horizontal length here would be equal to the horizontal length over here, but when we're talking about pi minus theta, the x-coordinate will be negative. So we've got a positive x-coordinate and a negative x-coordinate that are equal in magnitude. So we can say that the cosine of theta is equal to negative the cosine of pi minus theta, and that'll be true for angles in all quadrants as well. And now let's look at the tan of an angle. Now we know that the tan of theta will be equal to the slope of that terminal arm, and we can see that the rise over run for the terminal arm on the right, we've got a rise and we've got a run, and that rise over run is equal to the rise over run of the angle on the left. The difference being that the run of the angle on the left is negative. So we can see that the two terminal arms both have the same magnitude of slope. They're equally steep, but one has a positive slope, one has a negative slope. So we can make this relationship clear to ourselves here. The tan of theta is equal to negative the tan of pi minus theta, and that'll be true regardless of what quadrant theta is in. Now, another way of looking at that, if that discussion didn't make sense for you, is to remember that the tan of theta is equal to the sine of theta over the cos of theta. Well, we've earlier established that the sine of theta is equal to the sine of pi minus theta, and that the cos of theta is equal to negative the cos of pi minus theta. So we've got the same angle in numerator and denominator. So we know that the sine of an angle over negative the cos of that angle would be negative tan of pi minus theta. That's another way of establishing it if we like. Okay, so we've got the three identities shown here. Now, let's talk about when we've got theta and pi plus theta. Well, in that case, say for instance, we've got 40 degrees and 220 degrees, or 80 degrees and 260 degrees. If that's the case, we have a situation as shown here. Now, the sine value of an angle is equal to the y-coordinate. We can see, perhaps intuitively, that the length of this vertical arm is going to be equal to the length of this vertical arm, one of them being positive, one of them being negative. And so we can say that the sine of theta is equal to negative the sine of pi plus theta. And that'll be true regardless of what quadrant we're in. Now let's look at the cosine of theta. The cosine of theta is equal to the x-coordinate of the terminal arm, and that's going to be a positive number. The cosine of pi plus theta will have the same magnitude, but it'll be negative because x is negative in that quadrant. And so we can see that the cos of theta is equal to, and this should say negative, little typo there, negative the cosine of pi plus theta. Okay? Now, look at the terminal arms. They actually have equal slopes. The slope of this right here, that terminal arm, is equal to the slope of that terminal arm. So we can say the tan of theta is equal to the tan of pi plus theta. It'll be true regardless of what quadrant we're in. If we don't like looking at that graphically, we can still look at it algebraically. The tan of theta is equal to the sine of theta over the cos of theta. Well, the tan of theta is negative the sine of pi minus theta. The cos of theta is negative the cos of pi minus theta. So we've got the same angle in numerator and denominator. And by the way, these should be plus signs. Okay, a little typo here. These should be plus signs. And so what we see is that we've got the same angle in the numerator of that second line, pi plus theta, and the same angle as in the denominator, pi plus theta, but we've got negative sine of that angle over negative cos of that angle, so a negative over a negative is positive, so we've got sine of an angle over cos of that same angle, and so what we have is tan of that angle. So these should all be pi plus thetas because that's what we're talking about here. So we've got the sine of theta over the cos of theta equaling negative sine of pi plus theta over negative cos of pi plus theta, which equals the tan of pi plus theta. So in summary, we can write our summary slide like that. Now, let's look at theta and 2 pi minus theta. So for instance, suppose theta is 30 degrees. 2 pi minus theta would be 360 minus 30 degrees, which would be 330 degrees, just for example. Well, if we look at the sine of theta, that'll equal the y-coordinate of the upper terminal arm. And if we look at sine of 2 pi minus theta, that'll be the same magnitude, but it'll be negative. So we can say that the sine of theta equals negative the sine of 2 pi minus theta, and that'll be true in any quadrant. Now, looking at the cosine, we see that the x-coordinates are actually identical, and they're both positive. So we see that the cos of theta is equal to the cosine of 2 pi minus theta. It'll be true regardless of what quadrant we're in. And finally, we see that the slopes of those terminal arms have the same magnitude, but one's positive and one's negative, because the rise over the run of both will be the same, but one rise over run will be positive, one will be negative. And so we can see that the tan of theta will equal negative the tan of 2 pi minus theta, regardless of what quadrant we're in. But if we don't like a diagrammatic view of it, we can look at it algebraically. And we can say the tan of theta is equal to the sine of theta over the cos of theta. Well, the sine of theta is negative the sine of 2 pi minus theta, and the cos of theta is the cos of 2 pi minus theta. We've got the same angle in the numerator and denominator. So negative sine of that angle over cos of that angle is equal to negative tan of that angle. And we can make our summary slide right here.